Hi, this is Nalini Elkins with Industry Network Technology Council. We are recording this presentation on IPv6 troubleshooting. If somebody can send me a quick note to let me know that you're hearing me okay, that would be great. I'm getting some, great. Yeah, people seem to be hearing me okay. Let me know if anything happens and you can't hear. So, okay. As many of you may know, this is a presentation which is from a grant given to us by the American Registry for Internet Numbers and for IPv6 deployment. And the grant is given to our nonprofit industry consortium, Industry Network Technology Council. And if you are not already a member, we encourage you to join and help us. So, and we do a great deal of collaboration with the Indian organization, the India Internet Engineering Society, again, also a nonprofit. So, the vision is to have IPv6 deployment actually at the enterprises, because that is a place where we have been lacking in IPv6 deployment. The needs, of course, of large end user organizations, which we are calling enterprises, are quite different than ISPs, and so we are focusing on that. And starting, this is the last webinar in this series. And for next year, please do send me suggestions. I'm already getting suggestions. We already also have someone who will be doing a case study, and that will be wonderful. So that's great. We're going through they're going through the official authorization levels to get that, and so then once that is all done, we will announce it. Oh, and that's what we want to do. Is we want to talk about deployments. As I've told the people at my that I work with, I'm tired of hearing myself talk. I want to hear you guys talk about case studies. So this is the last class in this series, funded by both APNIC and Aaron. Just I'll flip past this quite quickly. I've been in the industry for many years, and you know what? I still get up in the morning and am eager to find out what has happened. There's this crazy stuff happening all the time. It's a great industry to be in. And whenever Mike is able to join us, he's been called away on an emergency problem, which I think you guys can all relate to. Then it would be great to have Mike join in and give his comments. So this particular webinar is going to be different from the other webinars that certainly that I have done. We are basically going to pull all the pieces together, everything that we've been talking about for this past year. And we're going to need all that information, because what we're going to do is pretty much spend the entire hour doing nothing but read packet traces. And that's where the rubber meets the road, right? Is when you're actually doing diagnostics, what are you seeing? And there are many ways to do troubleshooting and diagnostics. And what I prefer is, when you really want to know what's going on, then you need to look at a packet trace and really understand what is going on in the packet trace. And so that's what we're going to do. And we are fortunate to have Mike with us at this time. So Mike, I'm gonna ask you to chime in and give your thoughts trace reading and how useful Wireshark and all of that is.
No problem there, but I think I got here just in time because it sounds like you're trying to scare everybody away. Nothing but traces for an hour? Who would be crazy enough to listen to that? Well, there's plenty of us. I'll say that's not true because we're going to tell jokes and sing songs and pass out free food. But no, the trace reading is good. I think people are intimidated by it until they sort of get into it. But what I always like to say is it's the only thing that you can collect and get information on the situation that doesn't lie to you and is always dependable. My job is looking at logs and messages and application definitions and stuff, and sometimes that can be subjective or questionable or even wrong. But when all else fails, you resort to the trace if you want to understand the truth of the situation. So it's something that I don't think is bad. I think it's actually good, and it's something that's necessary. So let's get as familiar and comfortable with it as we can. So that's my thoughts.
Thanks, Mike. And we'll start with our first joke here. I know Mike, he always tells me, don't say this, but I'm going to say it. Because what I'd say for about 8-10 years ago, Mike and I used to spend maybe we'd get together one evening a month, and no, we didn't go out and get drinks or anything. We would sit together and read traces. and as I say, Mike is like, please don't tell people we used to do that.
Yeah, that's right. We don't want them to know how pathetic we are. Yeah.
But
that's addiction.
Yeah, go ahead, Mike.
No, I just said it's a sad addiction.
Yeah, but that's, as I say, one of the things that I'm going to show you is going to come exactly from one of those times when we were together and doing some stuff. So let me start now. So what I'm going to start with is I'm going to start with bringing up Wireshark. Okay, so for those of you who are not familiar with it, Wireshark is what I like to use most, and it's open source, and it's one of the best open source projects that there is. And if you guys have extra money, or who has extra money, but you should go ahead and donate to them. They're a great group of people, and they always need support. So okay, so what we're going to do is right now I have nothing up. Okay, I have no browsers up. There may be stuff going on, and I as I say, behind the scenes, Dropbox and so on. But so what we're going to do is I'm going to show you Wireshark and then start bringing up stuff, and it'll be super interesting to see what happens. So one of the first things I like to do is go ahead and set my my SSL keylog file, and so I'll point to that, and then I'll tell you what I'm doing. And then Mike can chime in on what he thinks about SSL keylog file. I know I'm a big fan. So you see what I'm doing? I'm going into TLS, and then I'm going to create a file name. And what it will do is right in there, it will go ahead and start putting in the master secret so that I can decrypt. I can decrypt packets. That's super useful. Mike, you want to chime in on SSL keylog file and whether you like it and if you use it and so on?
Yeah, I'm going to go a little bit higher level, and I'm also going to say I hope that we get people in the audience that want to throw something in the chat or talk about this live or even follow up with emails, because I think it's an increasingly important area that's coming at us like a big old freight train about to run us over. And that is that those of us that do traces, and hopefully everybody will be doing them after this session and loving it. We're used to, like, we get the trace, we put it into Wireshark or whatever our favorite dissecting tool is, and then we look at the packets and we figure everything out. Well, with the advent of a lot of encryption, we're not able to see the whole packet anymore. We can still see the TCP and IP header, but a lot of the stuff that's higher up than that, which is where a lot of the good information is in the application, presentation, and other layers, is encrypted, and it might as well be garbage. It's of no use. So what Nalini's talking about is one method to maybe get that back, and it takes some stepping through, and it doesn't work in all situations, so there's nothing perfect right now. Maybe Nalini's got it down to a perfect science, but I know for me, a lot of times it doesn't always work out quite as quickly or as well as I want it to. So this is an area that we need to be conscious of. I know just in my experience, I've had situations where I'm working with other organizations and we've had a similar problem that we did in the past, and the other side says, well, we'll just run a packet trace. And I'll say, I already did that, but guess what? We were using RSA keys, and now we're using DHE keys, and you can't decrypt it. And they'll say, like, well, I don't even know what that means, but we know it always works. And then a week later, they get back and they say, guess what? We can't decode the packet trace. So, and that happens, like your products will get upgraded, or for whatever other reason, you might be using a different key this week than you were last week or last month. And if that's a different type of key, it may be a different type of decryption that you're going to have trouble decrypting, and then you won't be able to get the information you want. So I know I'm belaboring this a lot, but I think, and Nalini, hope you can elaborate on this, I think there's work at IETF and other organizations to try to make this something that we will be able to decrypt in situations where we need to, because when we get all these newer keys out there and different cipher suites, and then when everything becomes TLS 1.3, we're not going to be able to see anything other than the network layers. So anyway, sorry if I belabored that a bit, Nalini, and hopefully you can add some clarity to it.
Well, I think we should do an entire session just on that. So I'm going to kind of put that off, because what he's talking about is essentially 4 years of our lives. And so you know, let's go to IPv6, and then say we'll do. There's another whole session that we need to do on that. So what let's just, you know, coming back to IPv6. What I've done right now is remember I've put all my browsers off. And what I'm doing is I'm just letting it run and to see what's going on. And you'll notice really that even with the browser off, let me stop this. Depending on where you are, I mean, as I say, I'm just filtering for IPv6, and let's just position and look at what we're doing. Because remember, I talked an awful lot, you know, in these sessions about the addresses and eyeballing the first portion to see what's going on. Because immediately that's where your eye should go. Immediately, the first thing you should be doing is things should be hopping out at you. You should be thinking to yourself, all right, I'm doing some stuff from a link local to a multicast address, and of course FF02::1 is what? All nodes. And here's one over to and I believe I saw something over from FF02::2. No, not yet. But you see what I mean? Is like, so this is where the rubber meets the road. Is what the heck is going on here? You're doing FF02::1. And in fact, what I'm going to do here, let me go ahead and apply as a filter. And I'm going to do everything to FF02::1. Well, looky here. Now this starts making some sense, right? Maybe, right? Because what do we see in here? We're seeing router advertisements from this guy. Now, let me ask you, who can send a router advertisement? Well, the router, right? I mean, unless you got something, you know, unless you're spoofing something. But if you're doing something legitimate, and this is my network, so I certainly hope everything's legitimate, then the only person who should be sending this router advertisement is the router. And what's he doing? He's sending it to all nodes. So what does that mean? This is an unsolicited router advertisement. How often is he sending it? Well, look to me like what? Every 3 seconds or so? 0, 3, 6, 9, 12. So interesting, huh? So it looks to me like this is the link local of my router. He's sending in router advertisements every 3 seconds. What's he doing that for? What he's doing is like, should somebody join my network, he's prepared, he's prepared to give them an address. And so by and large, so this should be a lot of the background traffic that you see is router discovery, neighbor discovery. And again, you see it's flowing as ICMP packets. Mike, got anything more to add on to this one?
Just a couple quick ones. Again, we're going to try to encourage you to do packet traces. And when you take a look at this, one of the things that if you're trying to familiarize yourself with whatever IPv6 is going on in your network, first off, you're going to see a whole lot more of it than you think. And at least that was my experience. Well, we're not running any IPv6, and all of a sudden there's gazillions of it out there. And like Nalini just did, you have to filter it out to take a look at the stuff that you want. So, but one thing when you do filter down, start looking at it, do exactly what Nalini's doing is look at the address types, and you'll see some global ones, and you'll see some local ones, and you'll see some multicast, and it's going to blow you away at first, but just get used to that like she's doing right now. Some of them are link local, some of them are multicast. I think before she applied the filter, there were some global addresses that we were seeing, and just get a feel for what those are and why they're different and why they're important. And that's all. Thanks.
Okay, so great, thanks. So now what I'm going to do, because remember, I'm still tracing. I'm tracing my my Wi-Fi interface. So let me turn this off. So what I'm going to do is I'm going to filter just for IPv6, and there's a ton of traffic. But what I'm going to do now is I'm going to go ahead and start tracing, and then I will bring up my I didn't shut down this one. Okay, so what I'll do then is I will bring up my Chrome browser, and then the next thing I'll do is I'll bring up my the Mozilla, the Firefox browser, and let's see if we see something different. Okay, so first thing I'm gonna do is let me start capturing. Yes, I don't want to save them. I got plenty of them. And so I'm going to go ahead and start, and then I'm going to go ahead and bring up. So right now, what we should be seeing, what are we seeing? Looky there. We're seeing router advertisements coming right up because I don't have any of my browsers up. Before, it looked like I had one browser window that was sneaking around in the background. And so this is good. This is real nice. This is what I want to see. Well, except that looky there, there's somebody who's got stuff going on that they had left open. All right. Never mind. Let's go ahead and we're going to go ahead and start up the browser. Come on, Betty. You can do it. Go to webinar kind of slows things down a little bit, as I say, but let's see what the trace is showing. Yeah, it's coming up. So, okay, here, my browser's coming up. Okay, all righty, he's up. And let's see what he's showing. So let's scroll down now. Because oh, good Lord Almighty, let's stop this. Okay, so you notice that when my browser is up, I've got a bunch of stuff that, he knows that I routinely go to a bunch of stuff. So he's going to go ahead and preload a bunch of stuff. Some of this dupe and stuff is sessions that used to be up. But you'll notice one thing, which again, we'll talk about it. This is something we're talking about a whole lot more coming up. One thing that Mike was alluding to is notice how much TLS 1.3 is out on here. And you'll notice that what I'm doing is, this was Chrome. And so all your browsers are going to have a whole different, they're going to default to a bunch of different stuff. And if you can, if you can, then they're going to want to go TLS 1.3. Because let's just see, even if we see TLS 1.2, I'm eyeballing and I'm not seeing it here, but I'm going to point out a couple of other things. So now, yes, the source and destination are different, but the TCP, TLS 1.3, I mean, it doesn't matter. It doesn't matter if it's IPv4 or IPv6. The TLS client hello, or whatever the upper layer is, it's going to be the same. It's going to be the same, so you don't have to worry about it. You know, it's what's going to be different. Of course, what's going to be different is the upper layer part here. This part here, the IPv6 part is going to be, you know, the IP layer is going to be different. But you'll notice is all this stuff. My network is Comcast, so it's going to go ahead and grab my source address, native IPv6, and it's going out native IPv6, and because that's what it would like to do, and that's the best, right? Is if it can, it's going to prefer IPv6 and go out that way, and everything is coming along the same. One thing you'll notice, though, the other thing that I want you to notice is how much quick there is. Notice also, though, that this is, I'm using the Chrome browser. Let's see if Firefox has that much quick. There's another whole session that we need to, talk about. I mean, there's so many things that, to discuss. As I say, some of the other things, you'll notice some of these things, the FEED. If you Google that, as I say, I want to kind of get past, I have so much that I want to talk about, and so I'm a little conscious of time. This is Comcast. If you Google the 2001 558 FEED 443, see, I mean, obviously, right, that he's going, that's their 443, but that's Comcast. And these are all global unicasts, but of course Comcast is my ISP. So why am I not surprised? Is to see so much Comcast. Everything else you're seeing now, you're seeing way less of the router advertisements. I mean, they are there, but there's so much other traffic that every 3 seconds is quite a bit. One of the things that I'll talk to you about later is Multicast DNS and also service location protocol. LLMNR also falls into that whole category, but let's throw that aside for a minute. So here we are. What we're looking at is global unicast addresses, a lot of TLS 1.3. Mike, any comments on this whole thing? I mean, we could talk forever, but
Yeah, not really. I'm just glad you hammered home the point that a lot of this, the TLS, the encryption stuff, and really anything at the TCP and above layer, is going to be the same in V6 and V4. So it's something that we need to continue regardless. And then the fact that we're looking at the IPv6 specifics today is really good.
Yeah. So let me take this browser down. I'm going to take that browser down. What I'm going to do then is let me start up the trace again. I'll start up the trace again, and I will bring up Mozilla. Let me see if I can find my Mozilla browser. Where the heck is my Mozilla browser?
Can I say something while you're doing that?
Sure.
Okay, and that is that. So Nalini showed you the router advertisements, and they were coming every 3 seconds. And that's something you discover, like when you do a trace. Did you know how frequently they're coming? Is that too frequent? And when you see that it's 3 seconds, and maybe that's too much because it's overhead on your Wi-Fi or whatever reason, then you know what it is, and you can go into the router and you can change that, and you can make it 10 seconds or a minute or whatever's appropriate for your network or that particular router segment.
Yeah, that's right. You learn an awful lot. By doing a trace. So I'm going to stop this now. So I brought up the Firefox. browser. And of course, some of the things we know from before. Here's my good old router advertisements. But look at here, interesting. They're going a whole lot more over. There's TLS 1.2, which I did not see using the Chrome. Let's see. I believe there's TLS 1.3 on here too. If I went to if I did a Google query, I would see that. But again, they're doing. I guess this doesn't even need to be said, but you know, they're doing IPv6 just fine, right? I mean, there's no need to worry that any of this stuff is not going to work under IPv6. And I don't know, that was not the case 5-10 years ago, but it's certainly the case now in terms of that kind of stuff. Now, having said that, I'm going to show you some stuff which you might do well to worry about. But at this level, at actually sending stuff over IPv6, you know, then that's nothing to worry about. Any questions from anybody or anything? Or Mike, what is your thought on you know, Mozilla? Oh, the other thing I'll say about Mozilla, notice we're not seeing quick either. It's so interesting, huh? Interesting what they prefer and what they go down to. I know that's upper level protocols, but still, I find that interesting. Yeah, Mike?
No, all I want to do is encourage people to ask questions and make comments to make sure we're moving in the right direction with all this. And then, and most of all, is it making sense? Are we hitting on the subjects that you want? So, you know, please be liberal with comments and questions. We're not easily offended.
No, for sure. Okay, so this is all good. So now I'm going to show you some case studies of some stuff that I want to show you for a particular reason. All right, so let me show you this one, and this will be familiar to you, Mike. It's been a while since you've looked at this, but this is going to be familiar to you. Let's start with what I'm doing here. So this is something, and I've been threatening to show you this particular trait probably this whole year. And this is something actually, you know.
Is this the multicast ping?
This is the multicast ping.
Okay, yeah, I do. And we haven't looked at this for what, a year and a half or 2 years or something? Yes, I remember it.
Oh, it's been more than that. So basically what I did is I did this. Ping to FF02::1. Mike, you wanna tell them what that actually does?
Yeah, I think we're all used to ping, and you usually ping an address. In this case, we're pinging a multicast address, and we're saying ping everything that's on this local segment. Oh, that sounds reasonably innocuous, but you don't know how much is on that local segment. There could be hundreds of devices. I mean, there could be one or two, but there could also be hundreds or maybe even thousands. And he's going to send out pings to every single one of them, and then you're going to get replies. And I think by default he does it 3 times. And suddenly you're sending all this traffic on your local link that, gosh, you're almost creating your own DDoS attack on yourself. And so that surprised me when I first saw it. And so I asked my expert, Nalini, I said, well, is that something that's of concern? And she immediately was, oh, God, yes. And we're going to take it to the IETF. And I think you took it to a bunch of people, and nobody else was concerned, or what did they tell you? That's how it's supposed to work? You tell me. The reaction wasn't what I expected.
Well, let me show you this, and then we'll tell you the whole sad story. Okay. So here it is. So we do this ping request, and so then ping works just like you think it does, right? So we get a ping reply. From who? Who's the source here? At the 8296. This link local, and so this is another somebody else. This is not him. There's somebody else on my local link, right? How do I know local link? What we've been telling you all this time, FE80. There's somebody else on my local link. He's coming back to me. So that's device one.
Responding unicast. Yeah, all the responses will be unicast. So sorry.
Here's device number 2 sending me something. Here's device number 3. 4, 5, 6. This is like, I'm like, geez Louise. And so, okay, so the one of the sadder stories behind all this is what we had done is we got some virtual servers from a hosting company. This was quite a few years back before, everybody had, add native IPv6 everywhere. And besides, it's like $5 a month, sure. And I don't want to mess up anything on my own PC. I mean, if something's going to happen, I want it to happen on the hosting server. As I don't want to mess up my own PC, and so I did that. But you know what? Let me ask you something. Am I like, Mr. Bill Gates or something, that I own 35 servers? Untrue. I had like 2 or 3 servers. I mean, even it's $5 a month. I mean, $5 a month adds up, right? I can tell the kids. But no, I mean, what do I need? 5,000. So what I'm telling you is this is a bunch of other people that the hosting service was hosting that were not even me. You see what I'm saying? Am I explaining that right, Mike?
I think so, but let's make sure, because I think it's important. So, like, of all these, and I don't know how many you said there were, 35 or maybe more different hosts that are out there. Oh God, there's hundreds, there's thousands.
Yeah.
So anyway, yeah, which the more there is, the more this hammers home the point that this can be a pretty serious issue. So maybe 2 or 3 of those were yours, and those are the only ones that you really should be having respond to you. And yet, if they're all on the same local segment, which means the same VLAN or the same local loop, then they're all going to respond unless you do something about it, or in this case, unless the hosting company does something about it. So there are things you can do about it, like doing some filtering in your switches, or maybe adding things to your local firewalls on you. But that takes work and understanding and stuff. So by default, this is what you're going to get, and by default, this could be a pretty significant exposure. So that's my attempt at, trying to re-emphasize your point.
No, I think that's really good, and I'm getting some comments which I will, share with everybody, because I think both the comments I'm getting are very important. So couple of things. So what Mike is talking about is, one, protect yourself. And that I'm going to come back to that over and over again. And in fact, our security study that we're going to be doing, I'm going to be sending out a thing on that. And because I think we need to really protect ourselves against some of this stuff. And it's a different situation than what ISPs have. So a lot of folks at the IETF are not thinking about it, are not focusing on it, and there may not be adequate protection. So that's why we want to tell you everything. Because, okay, so let me continue with this sad story. So now when I do, I use the same hosting company, but now when I do this, it's blocked. It's blocked because these people have figured it out. They've figured it out, and they're putting something in the firewall that doesn't allow me to do it. And that's what you guys should do too, is be forewarned that this can be a layer 2 attack. So one of the things that I'm going to say is, so a couple comments I have is you didn't show that it's also, I'm rephrasing, but what he says is completely true, is you didn't show that it's also it's loading its neighbor cache. He's exactly right. There's more to it than that. So there's a neighbor discovery packet, neighbor cache is updated. So it's even worse. It's even worse than what I'm saying. And the second comment is like, this is essentially a Smurf attack, which is a ping amplification attack. Bingo, 100% correct, 100% correct. This is, and that's why, okay, so that's why, so what happened then is, actually, I believe Mike might have helped me too, is I wrote up an internet draft, took it to the IETF, documented all of this, said blah, 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 yakety, yakety. And then a lot of folks at the IETF were like, this is working as advertised. And I'm like, seriously? Working as advertised? Are you kidding me? And so, but in essence, they didn't want to deal with it. And so that's why what I'm going to say is like, as I say, we need to, it's true, it's working as advertised, but we need to be forewarned. And I think we need to come back and, there needs to be more of it, there need to be more of it at the IETF saying, people, this is not the right way to do it. And we need to be involved as these protocols are being developed. We need to be testing them to say, is this kind of, behavior going to happen to us? That's why Mike and I keep encouraging people to join the IETF, because yes, maybe working as advertised, but we should know about this. So now I'm off my soapbox. Mike, what are your comments?
Oh, no, I think you said it all, and I just want to reemphasize what whoever said about the neighbor tables. It's kind of beyond this topic, because that's something you're not going to see in a trace. But we've done other webinars where we did a show neighbor display, and in Nalini's situation she was describing, you might want to, when you do the show neighbor, it's going to give you that's the equivalent of sort of your ARP table in IPv4. And, so who's talking to me on my local link? And you expect to see 2 or 3 or 5 or 10 devices. When you all of a sudden see thousands of them, that's going to take up space, not only in your memory of your device, but possibly in switches or other devices that are along the path there. And that could be a serious problem when the numbers get up into thousands like this. So whoever it was that said that was making a really, really good point.
Well, as I say, there's a whole lot more to talk about, because some of this, when Mike was talking about address planning, size of your network, segmentation and all that kind of stuff, it might not have hit home to you, but that it's all related. You know what I mean? It's like, that's what I say. It's like, this is where the rubber meets the road. Is how have you set things up? How have you set up your subnet? How is your firewall working? Do you have the right rules in? And as I say, let's go slow and steady. And as I say, you know what? I have 8 different traces, and I have others in case we ran out of time. I'm like wishful thinking, right? So let me continue, because believe me, there's plenty more. Guys, give me feedback too if you want, is because what we can try and do is like maybe every couple of months we can do one of these kind of sessions. Send me notes, if you guys think this kind of stuff is useful. As I say, I got 1,000 of these. So let me show you this one. As I say, it'll be amusing. So, okay. So again, it's like, I'm just going to tell you something. I have no life, right? You guys might have figured that out. So one of the things that I do, like, if I'm sitting around at the hotel, of course, nowadays with COVID, I'm not sitting around at no hotels anyway, but, so it's like, this is a while back when I was actually on an airplane, and I figured, somehow I was onto their Wi-Fi, and I'm like, let me just take a Wireshark packet trace. Let me see what's going on. And I'm like, eek, yikes alive, right? And so what am I seeing? I'm seeing a ton of multicast DNS. I'm like, what the heck? so what is multicast DNS? And then, oh my God, multicast DNS from what? Who you think all these other people are? Well, I'll bet you anything that Eileen is sitting over a few rows away from me or whatever. You know what I'm saying? And then I think there's Megan. I'm like, oh my God. And so, you know, one of these things, let's talk about multicast DNS in a moment. But now I'm going to tell you something. You know, I mean, encrypted DNS has its, how do I say, downfalls. But you know what? I should not be setting, I mean, this is not a trace that I want to make public or anything, you know what I mean? Because I guarantee you, I can probably find out way more about Megan and her PC than anybody would, you know, should be able to, you know? And so this is, it's a super interesting, you know, thing. But let's talk a bit about multicast DNS, because this is the kind of stuff that you are going to see a lot, this kind of stuff. Let me go back. No, do not make Firefox my, no, stop, do not be my thing. So let me go to the, hang on. Let me go back to the presentation, and then I'll show you multicast DNS. I've kept this here for you, so you have it. You know, like just memorize. As I say, just memorize the multicast groups, multicast scope. It will come in handy on you, because you don't want to be looking up all the time what it is. Like, you need to look it up. Here it is, the multicast groups. So what is multicast DNS? RFC 6762, so blah, blah, blah. But basically, what you're doing is doing DNS operations on the local link. And so if I'm sitting on the airplane, what is my local link, right? Everybody I'm sitting on the airplane with. I mean, seriously? And Mike, what are your thoughts? Let me go back to that trace. Hold on.
Yeah, only to reiterate what you said, that, you know, it's a heck of an exposure, and I think it's not the way most people would think it would work, because there's a lot of what you think might be private or at least isolated information there that isn't, and I think that was your reaction too.
Well, yeah, I did not think my local link was everybody, you know, in the airplane. So guys, so now if they haven't like, you know, cut off ping to FFO2:1, who you think's gonna answer? Everybody on the airplane? I mean, right? So I just DDoSed everybody on American flight, whatever. Oh, sorry, maybe I shouldn't say what you know, what carrier. But I'm sure it doesn't matter. It's any carrier. I'm sure all the carriers, you know, are doing stuff like this. You know what I mean? Does that make sense to you, Mike?
No, it makes perfect sense. And much like all the other concepts that you've introduced us to here, as long as you understand what's going on here and why, then you can kind of get your arms around it and control it if it's an issue in your network or whatever situation that you're in. But just to know that that's out there is kind of scary. And unless you understand it and understand how to deal with it, then it's not only out of control, but it's out of your area of responsibility that you can do anything about.
So I got a comment from one of the folks on the line saying MDNS has no security. Well, obviously, right? So I'm teasing, but guys, you know, send me a thing, because I have not looked. I didn't look it up, and I don't know if you have, Mike, whether MDNS is also a part of the what do you call it? The DNS over HTTP. Well, it's encrypted DNS. There's multiple DNS over LS and so on. I bet you it isn't. And so again, I think frankly, I think, frankly, down the road, I know NIST is setting up a lab, and
sorry to interrupt, but you really sparked me on that one, because I think it is not DOH capable, or the encryption because what are those things using for the most part? Point-to-point encryption like TLS. So until we have sort of a multi-point solution for encryption, I'm not sure MDNS can do anything about it.
Well, PDM version 2, maybe the stuff that we're working on. So there's a couple comments. Interesting. Okay, a couple comments. Okay, so MDNS really is not germane to IPv6. True enough. The problem, though, is that your IPv6 subnet is so much greater, So it can be the entire airplane. Of course, planes are not that big, so you could do that with V4 too. No, very true that it's an upper layer protocol, and we should get back to IPv6. But so hang on for 1 second, and I'm going to show you a V6 exploit. Well, I guess what I'll say, or maybe not exploit, but something that that surprised me. Let me say. And there's another comment that his home router lets him define a glass house SSID or network, so you can't see anything else, and it keeps his wife from downloading viruses onto the rest of your network. Excellent. But as I say, think about what all of this stuff. Oh, gosh, okay, we're getting close to time, so I want to show you one more thing. Okay, well, let's see what else I can show you. But I'll show you this for sure, because this is super interesting, because this is very distinctly going to relate IPv6 and and the upper layer. Okay. So what am I looking for here? Hold on. Yep, this is what I'm looking for. Let me see if I can. So what I'm going to do is I'm going to look for this. Okay. So what am I doing here? I'm keying in specifically on SRVLOC. Now, what the heck is SRVLOC? And why am I doing that? Okay. Let's get back to the presentation. Okay. SRVLOC is from 2608. I mean, that's a way old protocol, right? Service Location Protocol, a suitable scalable framework for the discovery and selection of network devices. Okay, so he's trying to find network devices. Sure. And it's intended to function within networks under cooperative administrative control. And really, basically, it's to find what services we have on our within your own network. You got printers, what do you got on your network? But let's go see. So let's go see what he's doing. So he's doing here. And so who's he querying? FFO2, people on my own link. What do we got? FFO1, people myself. I'm querying myself. But then what the heck? FFO5? What the heck scope is FFO5? Let's go back. Okay. FFO5 is everybody on my same site. So he couldn't find what he wanted on the link. And so he's querying everybody, anywhere to see if there's anything. And sure, I get it that he's trying to find services, but to me, it's like, I don't know, I freaked out a bit when I saw that. Mike, what is your reaction?
Oh, absolutely. I was going to bring this up earlier when you were trying to scare everybody on the multicast ping, and I was going to say one way to scare people even more is to expand the scope. And so you've expanded the scope to site here, which I still struggle with exactly what the definition of site is, but I think it's supposed to be like within your network kind of a thing, and I'm not sure how that gets bounded. So I'm still trying to figure that one out, and maybe that's another webinar someday. But then what if you expanded it even further? You know, like this is stuff that's just supposed to innocuously work and it's well intended. What if it was a nefarious hacker and they expanded it to 0.5 and that wasn't enough for him, and anyway did a 0E, the whole internet? So now the issue that we had before where we said, well, instead of a couple devices, we have thousands. Well, now you can have tens of thousands, and then you go to the internet and you can have millions or billions of devices and really explode things. So I think it gets really scary really fast.
Well, you got to just make sure you got the right ACL. I don't even know why they did FFOE to start with. What kind of scope is that? Seriously, what were you smoking? You know, I mean, you know, that's just crazy. That's crazy. But in any case, to me, I think we just need to this is why you probably ought to be doing traces, because you know, I'm getting some comments that service location protocol is very useful. No doubt. MDNS is very useful. You know, all these things are extremely useful. It's just that a ping is very useful. You have to create limits and create bounds and manage it. I think that's all Mike and I are saying.
Yeah, I think, if nothing else, I hope that what we're trying to do is motivate you to do traces and not be reluctant to do it. And I have a quick operational thing is, like Nalini's showing us Wireshark, which I think is absolutely wonderful, and I still can't believe it exists and it's free. It's just a godsend. So like, but on a Linux platform or anytime you're CLI based, you know, then you might want to go to either the Wireshark batch mode or in Linux platforms, or any Unix platform, TCP dump is another one that you should consider. You know, just familiarize yourself with that. It'll take a few steps and then you'll get used to it. And you can take the TCP dump PCAP or output that it produces and run that into Wireshark if you prefer looking at the dissected packets in Wireshark. So, you know, try a couple of those methods to get yourself going in this. And then, like Nalini said, until you do this, there's stuff going on, number one, that you certainly won't know about. And even when you see it, sometimes you won't believe it. So thanks, Nalini.
Well, guys, so I'm going to stop now because, as I say, we can talk forever. I have hundreds of traces, maybe thousands. No, maybe not thousands. Hundreds. I have hundreds. But let's take some questions and some discussion. And guys, if you want me to unmute you, I know some of you have been. Sorry, I'm looking at I did the wrong one. I know some of you have been sending me an awful lot of questions and comments. And so if any of you who've been doing that would like to be unmuted and just, you know, and join in on the discussion, I mean, please raise your hand and I'll unmute you. And also too, and while you guys are thinking, if you want to do that, then you know, otherwise I'll go ahead and read some of the questions because there's a ton of comments and questions, and I've read some already. But think about if you want to be unmuted. Also too, if you would like to present, you know, if you've seen problems, you know, if you've done stuff, then please go ahead and send me a note, and we can certainly arrange for that to happen. I get tired of hearing myself talk. So I'm going to unmute. Okay. So Joe, I think Joe would like to talk. I've unmuted you. I think you need to unmute yourself, and then.
Oh my gosh, it's a dual-sided. Allow me to communicate. Yeah. So the multicast ping, it does have value in a lot of cases, but it should be used sparingly. As an example, if you get onto a network and you're trying to do an inventory of what's on that network, especially if somebody has tried to slide a product connected to it, as an example, 10 additional cameras and a bunch of IoT devices, this allows you to receive the FE80s, take that last part of it, the last 64, is a EUI64, which is the MAC address. That allows you to then take that information out and look up what the product is. So if you're doing a quick inventory, that's a wonderful thing to do. Also, by doing this on a network that has IPv4 enabled, but IPv6 is not routable, you also end up with the same issue. So from a security perspective, when you're using dual stack, you have to make a business decision whether it makes sense to disable V6, which you really can't, or move to IPv6 only so you can avoid the crossover between ARP and this feature. Let's see. And also, when you do the FE80, it fills your neighbor cache. If you're in a disconnected network and you need to find services on a disconnected, say you're a hurricane comes through, you set up a network, you don't know who's on that network, but you want to actually find out what's available for your services. You know, is there printers, is there other devices, is there sensors, whatever. Things like the ping, and the ping specifically on FF01 or FF02 colon FB as an example, provides you the DNS for typically Mac devices or Linux devices. You can also look up SSDP by pinging the FF02 C, which allows you to do PNP. And then also to find a time server, because you really want, especially if there's encryption being used, you want to make sure that your local segment has a consistent time. This becomes an issue with things like, well, a lot of things. So you can actually ping for the FFO and then O2 to identify where the NTP server is. So what happens is that gets cached on each of your hosts, including the services. So if you're without a DNS, this gives you a secondary way of communicating until you can get backhaul or a valid connection through that router to the internet or to a larger network. So that function is very usable, and I've deployed it with in several situations.
So thanks so much, Joe. And I would love for, you know, if you have the energy and time, we would love for you to make a presentation. So on that.
Well, I'm writing one right now if you're interested on IPv6 and Zero Trust.
Oh, perfect. Yeah, let's talk. That sounds wonderful. Yep. So thank you so much. And then, so guys, thank you so much for everything. And this is the end of this series. And we're planning, you know, as I say, shoot me a note on what else you'd like to see, other questions. We will continue to have webinars. And you know, we have to like, we may take a little bit of a break now, you know, take a month or two break, and then hit the road again with case studies, various other things. Send me a note if you want to do more of these kind of troubleshooting webinars too. But or you know, I'd love to hear deployment stories. So thank you again for everything. Mike, do you have any final comments for everyone?
No, just to thank everybody for attending and letting Elaine know if we're hitting the right targets or what subjects would be best for future webinars. Thanks, everybody. Have a great day.
Yeah, thank you so much. Bye.